Determine the equation of the two tangents to the circle which are perpendicular to the line 5x plus 12y plus 9 equals to 0. Let us begin. So here we will first start with the equation of the circle. We are provided here the equation x squared plus y squared minus 22x minus 4y plus 25 equals to 0. This equation is given in its general form. So what we'll do, we are going to compare it with the general form of the circle, which is x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. That means 2g will be equals to negative 22. The value of 2f that will be equals to negative 4, and the value of c that's going to be equals to 25, which means g comes out to be equals to negative 11, f comes out to be negative 2, and c will stay as 25. The reason why we obtain the value of g, f, and c, because now we can define the coordinates of the center of this particular circle is usually given by, it is given by negative g comma negative f. So our center is going to have the coordinates positive 11 comma positive 2. And we also can define the radius of the circle, which is given by square root of g squared plus f squared minus c. Let's substitute this value. So we have g squared, so negative 11 squared, that will be 121, plus f squared, that's going to be 100, that's negative 2 squared will be 4, and then we have negative 25. So this will be equals to 10. So that means the radius of the circle is 10. Fine. Now we have the radius of the circle. We also have the coordinates of its center. So we have the circle here with the center having the coordinates 11 comma 2 with the radius equals to 10 units. Now our goal will be to determine the equation of the two tangents. So first we consider only a single tangent. Let's say this is the tangent, and this is tangent to the circle at, let's say, point A. And this particular tangent is perpendicular to, let's say, another line whose equation is given to us. The equation is 5x plus 12y plus 9. So let's use that other equation of the line. We have 5x plus 12y plus 9 equals to 0. We can find out the slope of this particular line. All we have to do is rewrite the equation as y will be equals to negative 5 over 12 times x minus 9 over 12. So this is the equation written in its slope-intercept form. So here the slope m1 will be equals to negative 5 over 12. So we will assume that the slope of the tangent, which is tangent to the circle at point A, be m2. By definition, we can immediately say that the product of the two slopes, m1 times m2, that must be equals to negative 1. And this is going to help us obtain the slope of the tangent line. So m2 will be equals to negative 1 over m1. So substituting m1 with negative 5 over 12, we're going to get positive 12 over 5. So now we have the slope of the tangent line. So we can assume, so let the equation of the tangent line, so we can define the equation of the tangent line as y, we will be using the slope-intercept form. We have y equals to the slope, which was m2, 12 over 5 times x, plus the y-intercept. We don't know the value, so we're going to call it lambda. Okay, now we're going to rewrite this equation in terms of the general form. So we have 5y equals to 12x plus 5 lambda. Or simply put, we have 12x minus 5y plus 5 lambda equals to 0. So this is going to be the equation of the tangent line. Our next task will be to obtain the value of lambda here. Okay, so let's do that. Now we have the coordinate of the center 11 comma 2, and we want to find out the distance CA. So we know this is we can use the formula for obtaining the distance of a point from a straight line. So if we have a point with the coordinates x1 comma y1, the distance of that particular point from the straight line ax plus by plus c equals to 0 is given by this formula. So here we have the point, which is the center of the circle. We obtain that its coordinates came out as 11 comma 2. And then we have the equation of the tangent, which we consider as 12x minus 5y plus 5 lambda equals to 0. We'll try to find out the distance, and this distance, this is the center. We have to point A, so CA will be given by according to this formula as absolute value, we'll take a. So a is nothing but the coefficient of x. So that's 12. 12 will get multiplied to the x coordinate of the center. So that's 11. Added to b. b is the coefficient of y, which is negative 5. So negative 5 will get multiplied to the y coordinate of point c. So that's 2. Plus the constant term, that's 5 lambda, divided by, we have the square root of a squared plus b squared. So that's going to be 12 squared plus negative 5 squared. Right. So here we have the radius. The CA is nothing but the radius of the circle. So this radius we obtained, that corresponds to the value 10. So that means 10 must be equals to, so we have 12 times 11, 132 minus 10 plus 5 lambda whole divided by, so 12 squared, that's 144, and negative 5 squared will be positive 25. That gives us 169. And we know that square root of 169 will be 13. So we get 13 in the denominator. Further simplification is going to give us, so we have 5 lambda plus 122. We'll take the absolute value. This will be equals to 130. So that gives us two possibilities. 5 lambda plus 122 could be equals to positive 130, or the other possibility is 5 lambda plus 122, that will be equals to negative 130. So 5 lambda will be equals to, so we have 130 minus 22, so that will be 8. Or the other possibility is 5 lambda will be equals to negative 122 added to negative 130, so that will be 252. Fine. So now we will substitute this into the equation of the tangent. So we have 12x minus 5y plus 5 lambda. So we have 12x minus 5y plus 5 lambda. So in place of 5 lambda, we're going to replace with 8. So this is going to give us one equation, and the other equation of the tangent line will be 12x minus 5y minus 252 equals to 0. Thus, these are the two equations of the tangent.